Section 2, Engineering Tools to Observe Atoms. This is found on page 10 of your textbook. Let's read the caption underneath the picture first. Atoms are on a scale too small to be seen with conventional tools. In the late 1980s, two physicists named Heinrich Rohr and Greg Bennig defined criteria and constraints to create a successful solution for the engineering problem of seeing atoms. Let me start back up at the top of your text now. Through the history of science, scientists developed better and better technologies and methods for observing smaller and smaller objects. Some microscopes allow scientists to see objects as small as bacteria and other microorganisms. X-rays allowed them to visualize the structures inside cells, but they still couldn't see individual atoms. So let's define the engineering problem. In the late 1970s, two physicists named Heinrich Rohr and Gerd Bennig decided to tackle the problem of seeing atoms directly. They knew about the existing techniques, but they decided that improving these techniques would not allow them to see objects as tiny as atoms. Instead, they tried to think of a completely new technique. The old wouldn't work. They needed something new. They wanted to develop a technique that would allow them to see, measure, and move individual atoms. These were their main criteria: to see, measure, and move individual atoms. Criteria are requirements that must be met for an engineering solution to be successful. Rohr and Bennig had to define their criteria precisely. It needed to have a resolution of at least 100 picometers so that it could see individual atoms. Skipping past the text again of the picture, normally engineers have to work within constraints such as time limits or strict budgets. Constraints are the limitations on the range of possible solutions to a design problem. Rohr and Bennig, however, worked in a research lab where they did not have strict or time budget constraints. They only had to consistently show that they were making progress toward a solution. However, they were limited by the technology that was already available. The technology did not let them see particles as small as atoms. Additionally, they had to take measurements so precise that they could not work when other people were in the building. They had to take measurements at night so that the vibrations of other people in the building did not ruin their results. Seeing atoms. Rohr and Bennig worked on possible solutions for many years. They built many devices and tested many different techniques. Finally, in 1981, they built a microscope that could reliably observe atoms. Unlike previous kinds of microscopes, theirs did not use lenses and light. Instead, it had a very thin probe that could produce and detect electric current. The microscope they created is still used today. The probe moves back and forth across the surface. When the probe is close to an atom, there is an electric current. When it's farther from an atom, there is less electric current. This allows the scientists to detect the shape of the surface so precisely that they can make out individual atoms. Scientists can observe the shape of atoms by watching how the amount of electric current changes as the probe moves over the tops of the atoms. It is similar to the way you can see Braille dots by running your fingers over them. Rohr and Bennig called their new microscope a scanning tunneling microscope, or STM. The STM was such a groundbreaking discovery that Rohr and Bennig won a Nobel Prize only 5 years later in 1986. The STM not only proved that there were tiny particles of matter called atoms, but also that the atoms grouped together in unique patterns. For the first time, scientists could clearly see atoms and what they looked like.